Other questions? Yes?
In discussion sections, is it just going to be like discussing things, or is it going to be like working on the problem?
It's going to be some of the, so the question is, what are the discussion sections going to be like? Are there going to be discussion of the problem sets, or is it going to be sort of general discussion of the course material? And the answer is both. I think there will both, in any given discussion section, there will probably both be an opportunity to talk about the previous problem set and to clarify things about the next problem set, and also some kind of activity that sort of extends and advances what we've been talking about in class. So I'm hoping to do some of both. If we veer too much in either one direction, that's probably not a good thing. There'll be other ways of getting help as well if you start to have trouble on the problem sets or in the course generally. I'll talk about those a little bit on Thursday. Yes, sir?
How are problem sets graded?
How are problem sets graded? Very carefully. Let's see. I think it'll probably be on a kind of 0 to 20 point schedule. But let me say this about the problem sets. There are going to be two kinds of things on the problem sets. One are kind of quantitative problems which have a right answer. Those are relatively easy to grade on some kind of a point scale. You give partial credit and so forth. But we will also, because this is a course that's not only about the specifics of this topic, but also about science in general, we're also going to have things that look kind of like essay questions on the problem sets. Those are a little harder to grade in this way, but we've got to grade them in the same way so that we can add the points up. And I'll talk a little bit more about how those are graded. I will say one thing that we do is we make sure that each problem is graded by each problem or essay is graded by one TA or by myself, so that we don't have different people, so that if you're in a section, it's not like all the problem sets for that section are all graded by your section leader and some other section leader grades all the other problems, because that leads to imbalances of various kinds. So we assign each problem to a specific person for the whole class. But it's basically a 0 through 20 scale, although what that means varies depending on what kind of a problem it is. I'll say a little bit more about that. I will also say there's a rather detailed lateness policy that's linked to the classes server. Please read that. We're going to stick to it. And one of the features of that is that there will be answer sheets. Problem sets are typically due Thursday. There'll be an answer sheet up the following Tuesday. So if you don't get it done by 5 days after it's due, you're toast because the answers are posted. Other questions? Great. Let's start. This is very cool. All right. This is going to be all kinds of fun. All right. Planets. Planets around other stars, but planets in general. So let's start by talking a little bit about orbits, planetary orbits. And you probably know some of this story. Originally, in the old days, people used to think that the Earth was the center of the universe. So the Earth was at the middle, and planets went around them in circles. That's not much of a circle, but you know what I mean. And so everything was circles around the Earth. And that's what planets did. Where planets also included to their way of thinking the sun and the moon as well. And so you had these circles around the Earth. This is what's called the geocentric model, Earth at the middle, and it's associated with the name of a Greek astronomer named Ptolemy. And the problem with this model is very simple, namely that if you actually go out and observe where the planets and the sun and the moon are night after night after night, it doesn't work very well. So this doesn't fit the observations. Doesn't fit observations. So they said, all right, well, maybe that doesn't work all that well. So what we'll do is, instead of imagining that the planets are on circles around the Earth, we'll imagine that there are circles on circles around the Earth, and the planets go on those. So you add a kind of extra circle here, so the circle goes around the Earth, and the planet goes around on that circle. These circles were called epicycles. So add epicycles. And what happened is they would add an epicycle, and then they'd go out and observe some more. And in particular, the Arab astronomers 1,000 years ago. 1,000 years ago, the center of all science was in the Arab countries. They gave us all our star names, by the way, are in Arabic. So are mathematical techniques such as algebra. And that all comes from the Arabs. They knew what they were doing back then when the Europeans were kind of in squalor. And they made these great observations, and every time they made more observations, it turned out it didn't fit, so they had to add in more epicycles. So then they added one here and one here, and so on, until you had circles and circles and circles and circles in order to explain the observations. And so add epicycles repeatedly. And this is kind of unsatisfying because it's not a good thing where every time you get more or better observations, you have to revise and extend your theory. That's not such a great theory. And in fact, the word epicycles has now become a kind of a swear word in the scientific community, meaning a sort of theory that has become so complex it's just ridiculous and you don't want to believe it anymore. And so, someone will come up with some really seemingly sophisticated but very complicated theory. And if you don't like that, you just go, that's just epicycles. Forget about it. So this has become a little bit of a swear word. And it was unsatisfactory at the time. All right. Now let me pause for a moment and confess that the story I've just told you, which is the standard story about Ptolemaic epicycles, it has what I think Colbert would refer to as truthiness. It's a commonly told story that people like to believe, but if you talk to the historians of science, this isn't actually how it happened. And in fact, this idea of circles on circles on circles, that isn't the way epicycles work. They had circles, and it did get more complicated every time they fit the observations, but not by adding more and more circles. They would move the circles side to side. They would have things going at variable speeds around the circle, all sorts of things. But this little picture that I've just drawn here has a kind of truthiness to it. And I would say that this is a general issue with the way scientists describe how science works. We tell these nice anecdotes, and we put them in the textbooks, too, in the little bars that go down the side of the textbook, where you get the head and shoulder shot of the famous dead white male scientist and so forth. And then we tell these stories. And the historians of science hate this because it isn't actually what happened. Nevertheless, we persist in telling these stories. And I've been thinking about why that is. I think the way to think about this is what these stories are fables. And like any fable, the point is not that the story is true. The point is that it vividly illustrates a moral, which tells you how to behave or how not to behave. And they're useful for that reason. You'll recall the famous fable of the ant and the grasshopper, right? Grasshopper sings and plays and dances all summer long. The ant is very industrious, piles up food, doesn't have any fun. But then in the winter, the grasshopper starves, and the ant does fine. And if an entomologist were to come along and say, but that's not how ants and grasshoppers behave, you would correctly say that he's missed the whole point. And the point is that it's just a nice story which illustrates certain kinds of behaviors and whether they're good or bad. So here's what I'm going to do. I'm going to tell these stories, but I'm going to label them fables, and I'm going to point out the morals explicitly. And the optional paper is going to be to go and take any one of these things and find out what really happened